Hi everyone, and welcome to our video on linear functions. So linear functions are lines when they are graphed. They have this common form, y equals mx plus b, where m is the slope and b is the y-coordinate of the y-intercept. And they're very common, and they're usually easy to work with. So let's use this example to show what a linear function represents. Now, they have this form, y equals mx plus b, but they would also have this form, f of x equals mx plus b. Where this f you can change to a different letter as needed. So for instance, on this problem, it's probably a good idea to change it to be like capital C because it mentions cost. Okay, so let's read this. So and it also has selling involved too. So we have two functions here. Okay, so it says Jack sells ice cream for $5 a cone. It cost him $3 per cone with a fixed cost of $20. How many cones must he sell to break even? Find the revenue, cost, and profit functions. Okay, so we're going to break this down into these pieces. Okay, so Jack sells ice cream for $5 a cone. All right, so so anything that involves sales is revenue. Okay, so that's going to be our revenue function part. So I'm going to write my form. Now, instead of f of x, I'm going to do r of x equals mx plus b. So it doesn't say that it's linear, but it certainly looks like it is, and we could figure that out based on how it's $5 per cone, so there's nothing else going on with it. And with this $5 per cone, whenever or it says a cone, but that's also the same as per in this scenario. So Jack sells ice cream for $5 per cone. Well, this $5 per cone, this will help when it's linear functions to denote the m. So the m is the slope, but it's also something involving the per, or it's something involving marginal. So these are other words that they might use in these problems. Okay, so for instance, this m in our revenue portion will be just 5. And then we'll attach the x to it. And then because there's nothing else about sales in this scenario, that means this is it. That is our revenue function. Okay, and then we go into cost. Let's do that in blue. So it talks about cost, $3 per cone with a fixed cost of $20. Okay, so the fixed cost in our scenario for, let's go ahead and write it right here. So our cost function, we will have c of x equals, it's the same linear form, mx plus b. Well, here we see the per, so that means that will get attached to the x, so we have 3x. The fixed cost will be what the b is, so plus 20. So b, when it talks about costs, is a fixed cost. So it's 3x plus 20 would be that function. Okay, and then the next part is asking how many cones must he sell to break even? So a break even point is where the revenue is equal to the cost. So that means we'll set our two equations equal to each other. So we would do 5x equals 3x plus 20, and then we would solve for x. So to solve for x, we can subtract the 3x to both sides to get 2x equals 20. And then we can divide by 2 to get x is 10. Okay, so that's the number of cones. So x, so we didn't mention it. It's usually a good idea to mention that. Let me go back and put a little star. Let's do it in orange. Okay, so since they're talking about cones, selling or having the cost for cones, that should give us a good idea of what x is. So x is the number of cones. Okay, so that's a good idea to write out at the start. I should have done that. But I think maybe we could have figured it out before then anyway. All right, so we do have x equals 10, and then let's put the unit, cones. And that's what it was asking for. How many cones must he sell to break even? So 10 cones. So that means anything less than 10 cones, Jack would be losing money. More than 10 cones, he would be making money. All right, and then it asks for a profit function. Okay, so we did cost in blue, we did revenue in black. Let's do our cost function in purple, or in profit, profit function. Profit, in words, is the revenue minus the cost. So we can do P of x equals R of x minus C of x. And then now we can plug those in. So our profit function, when we plug these in, we would want to make sure we use parentheses. And let me go ahead and just kind of set up a big thing for it there. Okay, so our revenue was 5x. Our cost was 3x plus 20. Okay, and then that negative will distribute. Okay, so I kind of ran low on room. Let me write it up here. So our profit is 5x, and then the minus distributes to be minus 3x minus 20. So the negative distributed all the way through. And then 5x minus 3x we could combine to make 2x. So the profit function is 2x minus 20. Okay, so that means we could plug in the x value for a number of cones and see what the profit would be made for however many get sold. Okay, so this is linear. Okay, so all of these functions, we could plug them into the calculator to see what they look like. So y equals f of x, y equals 3x plus 20, and y equals 2x minus 20 if we wanted to see them. Okay, so that's how we could graph them all. We have other videos on how to graph these linear functions, but for now, that's all. So that means that's all I'm going to say about it for this. Okay, so that's what we wanted to do. So if we wanted to graph it, we could, but you can check out a different video. All right, so the next type of problem is still using our linear form, but let's make sure that we have all the information that we want. Okay, so this says Jill likes to bake bundt cakes, and currently the cost of her bundt cakes can be modeled using a linear function. Okay, so we know linear function is definitely involved this time. In the previous problem, we were assuming it. It says if it costs $70 to make 10 bundt cakes and $100 to make 20 bundt cakes, what is her linear cost function to make X number of bundt cakes? Okay, so they're telling us this time too, X is the number of bundt cakes. And they say it's a linear function, and since it's cost, let's do C of X equals, and then it should be mx plus b. Okay, so we'll come back to this. So this one's not as nice as the previous one where we could just plug in those numbers. Instead, they give us this information. Okay, so it says if it cost, let's mark this in the blue, that's one thing. So they're saying if it costs $70 to make 10 bundt cakes, so I'm going to write this as a point. So we have, let's make it even as a table. So when there's 10 bundt cakes, the cost is 70. And so that's the same as our C of X. I'm just writing it as coordinates, X and Y. And then the second one, let's go ahead and do that in green. $100 to make 20 bundt cakes. Okay, so 20 is the bundt cakes. $100 then would be the cost. Okay, and so what we have here with this information, it would give us a line. So let's say there's where 10 is, and then there's where 20 is. 70 is somewhere up there about, and then 100 somewhere up there. Okay, so we have this linear cost function with our 2 points. So there's 10 comma 70, and then there's 20 comma 100. Okay, well, when it comes to lines, what's nice about them is we can find the slope based on the rise over the run. Okay, so that triangle, so this part is the run, this part is the rise. There is a formula you could use. So rise over run is the general saying we could say, or you could say it's the difference in the y coordinates, so y2 minus y1 over x2 minus x1. Okay, so this would be my x1, x2, and this would be my y1, y2. Or we can even label it on our picture, x1, y1, x2, y2. Okay, so that's how we could use the formula. We could also just count if our grid, or if we can see it good enough. So for instance, like if we start at 10 and go to 20, our run would be a length of 10. Okay, so the difference between 10 and 20 is 10. Okay, so that means our run, it should be 10 if we wanted to check it with our equation. I'm just going to write it down there too to verify. And our run, well, our run, or I said run, our rise is this difference. And we can see, well, 70 and 100 is a difference of 30. So that means our rise should be 30. And then from there, 30 and 10 would simplify to be 3. Okay, so I wrote that there. To double check, I could plug it into the formula. Okay, so y2 is 100 minus y1, which is 70, over x2, which was 20, minus x1, which is 10. Okay, and so that does simplify to be 30 over 10, which eventually simplifies to be 3. Okay, so that means we have our m, but we don't have b yet. So 3x plus b. Okay, so I'm just kind of filling in what I currently have. Well, what we could also do with this equation, there's 2 ways we can go from here. What I need to figure out is what b is. I can continue using the graph. If I draw it accurate enough, I can extend this and continue to use my slope to figure out what this y-intercept is. So that can help find b. Or another way to do it is to plug in one of these points and to find b in this equation right now. So for instance, let's let x equal 10 so that we can find b. If I plug in 10, I would have 3 times 10 plus b. So I'm evaluating this linear function like we normally would. However, they are saying, let me highlight again, that this cost, remember this is the y-coordinate when x is 10. So that means I could replace that with 70. 3 times 10 is 30 plus b. So that means now I can solve for b. If I subtract 30 on both sides, we would get b is 40. Okay, and let me kind of cloud the 2 main things. Okay, so the 2 clouded things are what gives us, let me rewrite the cost function one more time. So there it is as its normal, just general form. But now we have the values. So we would say c of x equals, and now all we're doing is just replacing the m and the b. So we'd have 3x plus 40. There we go. So that is her linear cost function to make x number of bundt cakes. Okay, so that's how, so linear functions are common like this. You got y equals mx plus b. You can make sketches of graphs. The m has some extra information on it too. All right, so if you do have questions though, there are other videos that are also available on linear functions. There's a lot of them actually. So this is more of a recap with what our current topic is, with just kind of evaluating functions is kind of the main thing. Okay, so anyway, so check those out if you need them, or let me know if you have questions. Otherwise, thanks for watching, and I'll see you again next time.